Hello everyone, welcome to the limit solution videos for the worksheet that was given. Before we get right into it, I want us to go over some factorization. Based on what happened in class on Thursday, I realized that you guys still need some more practice with algebraic manipulations and factorizing, because much of limits is simply recognizing when something could be factored very quickly. One of the most common expression that is given that needs to be factorized is the difference of squares, or the difference of perfect squares, which is an expression in the form a squared minus b squared. This could always be factorized as a minus b into a plus b, or a plus b and multiplied by a minus b. It wouldn't matter which order you put it. This could be anything. It doesn't even have to be anything with an x. It can be numbers. For instance, 3 squared minus 2 squared is the same thing as 3 minus 2 multiplied by 3 plus 2. Right? If you don't believe it, you can put in your calculator and check it out. Alright. You could also have 1 minus x squared. 1 minus x squared is still a difference of 2 squares. Why? Because 1 is 1 squared. So this is still in the form a squared minus b squared. So you can factor this as 1 minus x multiplied by 1 plus x. Right? The x could be in front, x squared. This could be x squared plus 1. This is still a difference of, it's still a difference of 2 squares. Sorry, x squared minus 1. It's still a difference of 2 squares because x squared minus 1 or 1 squared is the same. X squared plus 1, that is a different thing. You're splitting them all together there. I'm giving you a short tutorial on difference of 2 squares. And so when you see a square, a term squared minus a next term squared, this is always alright. I'm in room T104 right now, and there's some construction going on, so you will hear some noise, some more noise in the later parts of this video, and sometimes you might just hear me refer to this as perfect squares. I mean difference of perfect squares. A perfect square is, I will say that later on also. Alright, so let's get right into the work. What is the first question? The limit as x goes to 0 of sine 3x over 4x, or is it the other way around? 4x over sine 3x. Alright, so this is our first question. So we plug in 0 here, and we will get 4 times 0, 0 divided by 0, right? And then you write in determinate form. Then step 2, try to factor out x minus a. In this case would simply be x, because a is 0. Could we do that? Nope. You could factor out an x here. You can't trouble anything in there. So does it resemble any of the trig rules, the limits, the trig limit rules? Yes, the first one. The limit as x goes to 0 of x over sine x is 1. But we have a 3x here and a 4x there. It would work out very good if this was 3x. So how could we make it 3x? How could we make 4 into 3? We need to multiply 4 by something, and the answer would have to be 3. What we simply do, what we want equal to, we put it at the top here, we put the 4 at the bottom there, right? So that will simply cancel with that. So we multiply 4 by 3/4, get 3. And now we use a method for any, whatever you want, if you want to turn any number to the next number, let's use the appropriate fraction. So we need to multiply top and bottom by 3/4. So on our second line, we have the limit as x goes to 0 of this, go with that, 3x divided by 3/4 of sine 3x. Now from here you could just write 4/3 as the answer, since you could basically see it, or you can expand this just a little bit more. You know, here we have x over sine x, calling 3x the entire x term. So we have a limit of 1 over 3/4 multiplied by the limit as x goes to 0 of 3x over sine 3x. Right? Remember, limit as x goes to 0 of x over sine x. It doesn't have to be an x. Because whatever is here must be there. Right? So we have the form. So all this will just be 1. All that will just be 1. This is just 1, and 1 over 3/4 is 4/3. So this is 4/3 times 1. So the answer is simply 4 over 3. And that is our answer. Alright, next question. So the limit as x goes to 0 of 4x divided by sine 3x is simply 4/3. Number 2, the limit as x goes to 1 of, what do we have, x squared minus 1 divided by 1 minus x. Alright. You plug in 1, you get 1 squared minus 1, 0 over 1 minus 1, 0. 0 over 0, indeterminate form, determinate form. So we factored x minus e. We want to factor x minus 1. You see 1 minus x at the bottom. You see x squared minus 1 at the top. We know if we multiply this by -1, we will get x minus 1. But there is no x minus 1 here at all. But if you look closely, we do have a perfect squared there, right? Difference of perfect squares there, right? Yes, because we have a number squared minus a next number squared. Taking into consideration 1 is 1 squared. So we have x plus 1, or x, it doesn't matter which you put first, x minus 1 multiplied by x plus 1 divided by 1 minus x. Now, this is almost this. This is 1 minus x, this is x minus 1. So, how could we get this to look like the x minus 1 that we want? We can do that by simply factoring out a negative sign. So, instead of having 1 minus x, we factor out the negative, and the signs of everything in the brackets will change. Right? If we multiply this back, we would have 1 minus x. So we didn't change anything. But here we have this and this now being the same. Because I could rewrite this as, this is -1 plus x, which could easily be rewritten as -1 plus x is the same as x minus 1. Right? So you clearly see this goes out with that, and what remains is x plus 1 divided by -1, right? So what we have, I will have to move this camera. What we have from here is the limit as x goes to 1 of x plus 1 divided by -1. You put 1 in there, you have 1 plus 1, 2 divided by -1, which is equal to -2. Alright, next question. Limit as x goes to 0 of the square root of x plus 2 minus root 2 all over x. So if you plug in 0, you get root 2 minus root 2, 0 over 0, 0 over 0. You write indeterminate form. Next line, try to factor out x minus e, which is just x in this case. So we look, we see we have an x here, we have an x there. There is no trig ratios that are blocking it. So there must be a way we could factor out that x, even though we can't see it plainly. Now there's many things that you might have to do before you can factor out that x. Sometimes you have to maybe expand some brackets, apply and multiply the top and the bottom by conjugates when dealing with surds, and many other methods. But you do whatever you have to do to get the x out of the square root, under the square root, because we want to get rid of x minus a, which is just x. So we want to find our x and eliminate it for all the trouble it's causing. So we look for our x. We multiply. When you have surds, I am sure you should be comfortable with rationalizing surds. When you multiply top and when this is at the bottom, especially you multiply the top and the bottom by the conjugate of this. Conjugate just meaning change the second sign. This is multiplied by the root of x plus 2 plus root 2. If this was plus, you would have multiplied it by this minus that. Conjugate just means you change the middle sign. Conjugate. So you multiply the top and the bottom by the same thing, so as to not change the equation. Now what do we do from here? This looks like the expanded form of the difference of squares, or difference of perfect squares. It does, because I see something minus something else multiplied by the same thing plus the same thing, right? So this is in the form a minus b multiplied by a plus b, which is the expanded form of difference of squares. So this is equivalent to a squared minus b squared. Since a is the square root of x plus 2, and b is the square root of 2, then if I'm going to write a squared minus b squared, then it would be, this is a, this is b, it would be the square root of x plus 2 squared, which is simply x plus 2 minus b squared. B is b is a root of 2, so root of 2 squared is just 2. So this is a squared minus b squared divided by, I wouldn't multiply this into that and that into that, because I want to, we're trying to eliminate our x, the x right now. So we wouldn't want to multiply it, and we want to separate x. So we leave this x there, x multiplied by, we leave it in this form. we're trying to get rid of this troublesome x, right? Now what do we have? We have the limit as x goes to 0 of 2 minus 2 is 0, x over x multiplied by root of x plus 2 plus root of 2. We found u. So this now becomes simply 1 over, this is x plus 2 plus root 2. You plug in 0 there, and what you will have left is, 1 divided by root 2 plus root 2, which is 2 root 2. I hope you're going to tutorials, so these things are getting simpler for you. So the answer is 1 divided by 2 root 2. That's that. Alright, now you notice that all these problems are testing how quickly and how sharp you are at recognizing difference of two squares. This is more like it. Now, where were we? The limit as x goes to 0 of cos 3x minus cos x all over x squared, and we said this was 0 with 0, or indeterminate form. And we chose to do a sum to product. Now, as a tip, every time with this course, you see something looking like this, and you want to find a limit, and you see that the limit is 0, doesn't matter what the cosine is. Cosine 3 times anything will still be 0, or sorry, 0 times anything will still be 0. So you always have cos 0 minus cos 0, even if this was 7x or 8x, etc. So cos 0 is 1, so you always have 1 minus 1. So there's no way to remove the 1 minus 1 unless you completely remove this identity and bring in a next identity. So what would we do? Since this is the sum, what we could do, remove, but it's the sum or a difference, what really matter. It's a sum of a negative number. Anyway, this is a sum. We could replace the sum with a product, and perhaps we won't get 0 anymore. Let's check it out. So we use the sum to product identity, and you see that cos of, I think the paper I gave you had u and v, cos of u minus cos of v. Doesn't matter if you use u and v or a and b or whatever, but I think you had u, cos of u minus cos of v is equal to negative 2 sine a plus u plus v over 2 times sine u plus v, u minus v, sorry, over 2. Right, so we're going to convert this into this. How do we do such? In this case, cos of u, this is our u, this is our v. So translating this to this, we would have the limit as x goes to 0 of this becomes that. So we have negative 2 sine u plus v divided by 2, 3x plus x divided by 2, 4x divided by 2 times sine u minus v divided by 2. 3x minus x, 2x divided by 2. 4 divided by 2. This is just 2 into 2, 1. So this just becomes sine 2x times sine x all over x squared. Now, even though we still can't factor out anything, and we still have 0 over 0, this time I see a trig rule. I see something looking like sine x over x, because I see a sine x and I see an x here. Just that there are two of them. So what I could do is, this is at the bottom of the board, what I could do is rewrite this as the limit as x goes to 0 of negative 2 sine 2x over x multiplied by sine x over x. Correct? Good. Now I clearly see I have a sine x over x here. Limit as x goes to 0. But here I don't see a sine x over x. But I see something very close. I see a sine 2x over x. So what do? We could multiply this by 2 to make it sine 2x. To make it match with sine 2x, multiply that by 2. But if we're going to multiply the denominator by 2, I have to multiply the numerator by 2 also. So I put multiplied by 2. So this now becomes the limit now. Two of those things would go directly to 0, directly to 1 because of the limit. Which two? We see here we have the limit, and let me split it for those who can't see. We have the limit as x goes to 0 of negative 4 times the limit as x goes to 0 of sine 2x over 2x multiplied by the limit as x goes to 0 of sine x over x. So obviously this will just be negative 4 multiplied by this, it's just 1, multiplied by this is also 1. So the answer is negative 4. And that's that. Next question. Sine 5x minus sine of 3x divided by sine x. So what do we have here? Plug in 0, you'll definitely get 0 over 0 again. So you write indeterminate form. Here you write indeterminate form there. And you do just what I said just now. Replace with a sum to product identity. So the sum to product identity is, we see that sine of, you think you have u. If you look on it and you see sine of a, sine of x, though, it doesn't matter. Sine of whatever it is here, sine of u minus sine of v could be written as 2 cos u plus v over 2 multiplied by sine u minus v divided by 2. Alright, so let's go. What is u? This is u. Look at yourself. And this is v. Alright, so we're gonna rewrite this in that form. A sum to product identity. So we have the limit as x goes to 0 of 2 cos u plus v over 2 5x plus 3x 8x divided by 2. 5x u minus v over 2 5x minus 3x 2x over 2 all over sine x. Alright, so this cancels. Sorry for the noise in the background. I'm now at UG. So you hear the construction. I don't. Alright, so this now is just cos of 4x times sine of x. Cos 4x sine x divided by sine x all over sine x. Now what do we do here? Do we look for sine x over x and try to divide the top by x and divide the bottom by x, and you will get sine x over x, numerator and denominator, or you can just notice that you have a sine x and a sine x there and just cancel the two sine x's. So this is equal to 2 cosine 4x. Now the limit as x goes to 0 of 2 cos 4x, you put 0 in there, you get cos of 0, which is 1. 2 times 1 is just equal to 2. And that is it for here. So those were two examples of limits to trigs where you had to use a substitution. Next, number 6. The limit as x goes to 0 of 1 minus e to the 2x divided by 1 minus e to the 2x. What is this? Well, I don't know how long you spent trying to work this question, but everything that's at the top is also the bottom. So this is just 1. This is just 1. Yes. However, let's work a different question. The limit as x goes to 0 of 1 minus e to the 2x divided by 1 minus e to the x. Which I highly suspect that this is what the question is supposed to be. So, let's go. Put 0 in here, what would you get? 1, if anything to the 0 power is just 1, so you have 1 minus 1 equals 0, 1 minus 1 is equal to 0, 0 over 0. Indeterminate form, please actually write it in the exam. Why did I not plug in to get 0 over 0 before? Because the same thing on numerator was in the denominator, so you could just cancel it. Anyways, this is the actual question we're going to work with a single x there. So you get 0 over 0 in determinate form. What do you want to do? Factor out x minus a, in this case x minus 0, in this case x. You can't factor out an x, at least not easily. So alright, we should try to factor out something. I said if there is no x to factor out, the next thing you can do is to try to expand brackets. Still, the expanding brackets and the multiplying by the conjugate like we did earlier, it is all still to the effect of factoring out the x. So that's still technically the only rule. The conjugate part we went down, multiplying by the conjugate, and if you have to expand brackets, etc. Those are just different methods or different paths to get to revealing the x by itself, or to get to some part where we factorize and cancel as usual. Alright, now could anything be expanded here? Do we see any perfect square? Do we see any a squared minus b squared to expand it into a minus b multiplied by a plus b to factor out, to cancel factors? Do we see anything like that? No. Or do we? Do you see a perfect square here? There is actually a perfect square here. 1 minus e to the 2x is a perfect square. Why? Because from the laws of indices, a to the b multiplied by a to the c is a to the b plus c. So e to the x multiplied by e to the x would be e to the x plus x, or e to the 2x. So e to the 2x is ex squared. So we have 1 squared minus ex squared. That's what this actually is. So we could, sorry for the noise again, construction. So we could put this perfect square in expanded form. So you know perfect squares, a squared minus b squared is equal to a minus b multiplied by a plus b. And we recognized e to the 2x as being ex squared, ex times ex. So this is the same as 1 minus e to the x, 1 plus e to the x, all over 1 minus e to the x. I'm not going to do a video in again. It's very noisy. Alright, this goes on with that. And what remains is the limit as x goes to 0 of 1 plus e to the x. Put that in there. Anything to the 0 power is 1. So 1 plus 1. And we have the answer as being 2. And that is that. Alright. Next question. Number 7. The limit as x goes to 0, as x goes to 1 of x cubed minus 1 all over x squared plus 2x minus 3. Alright, so plug in a 1, you will get 0 over 0. So you write 0 over 0 indeterminate form. You factor x minus a, which is x minus 1. So you know, well, from how it looks, you definitely know this one could be factorized. If you check you do the test to see if simple factors exist in this equation, you'll see that they do. So we factorize this into course, this one is simpler. Sorry, x minus 1, x plus 3. That gives that. And what do we factor that x to the third power minus 1 into? I could just tell you the answer, but what would you do on your own if I don't want to put the answer. What would you do on your own in a case like this? You know you want to take x minus 1 out of it because you want x minus 1 to cancel the x minus 1 here. So when you factor out x minus 1 out of x cubed minus 1, what do you get? Let's say you're in an exam, you really don't know what to do. This could be presented in a million different ways. It could be x to any power, and you gotta factor out something you don't know what would remain. What you could simply do is just divide. You know you have to turn this into x minus 1 times something you don't know what it is. Then just do polynomial division and divide this by this. So let's do that quickly. X minus 1, x cubed plus 0x squared plus 0x minus 1. So x into x cubed is x squared. X squared times that is x cubed plus 0x squared plus, x cubed minus x squared 0. Subtract this, we get 0 plus x squared plus 0x minus 1. This into that plus x times that x squared minus x. Subtract again. I'm coming off. You subtract again and you would get, so subtract, this is 0 minus negative x, you just get x minus 1, x into x, 1, so you put plus 1 times that is x minus 1. This subtracts into 0. Right, so whatever, so we know that this is what will remain. So we come up here, and we write x squared plus x plus 1. And that is that. Now I wouldn't want to see all this working in your books or your paper, not necessarily. You won't get any marks for this. Right? That's just to help you to factorize. If I put something very weird on the board and you have no idea of how to factorize it, but you know what you want to pull out to cancel, then that's what you do. You just divide what you have by what factor you know you want to come out of it. So that and that goes out. We eliminate the x minus a, and what remains is the limit as x goes to 1 of x squared plus x plus 1 divided by x plus 3, which is equal to 1 plus 1 plus 1, 3 over 4. So this answer is 3/4. Next question. Next question. Limit as x goes to 0 of sine x divided by tan x. Alright, now if you put this in here, you will get 0 over 0. Again, you write indeterminate form, and you can't factor out x minus a. You don't see anything looking like any of the two limit rules that we looked at so far. But you remember the rule that says, if I see the trig ratios that are not sine and cosine, I should, or you don't have to, but it is very helpful many times to convert all trig ratios as much as possible into just sines and cosines. So we have tan x, so let's convert that. So tan x is sine x over cosine x. Now this, of course, is the same as sine x multiplied by cos x over sine x. And look at that. You can see this goes with that. Limits as x goes to 0 of cos x, put 0 in there, and the answer is simply 1. Right, next question. The limit as x goes to 0 of tan 2x over 5x. 0 over 0, do the same thing. You can't do step 1, you can't do step 2. Let's see if we can simplify. So sine 2x divided by cos 2x over 5x. Convert tan into sine and cosines. Alright, now what do we have here? Alright, now let's make this a little bit, let's write this in a different way so we can clearly see what's happening. We have sine 2x over cos 2x divided by 5x. And remember I said when you're dividing something, consider it as, if you're dividing by x, consider it as being as that you're multiplying by the reciprocal of x. So you have this divided by 5x, so you would want to rewrite that as this. Instead of saying divided by 5x, you'd want to rewrite it as that multiplied by 1 over 5x. Now when you do this simple rewriting or re-expression, you will see we have something looking like sine x over x. Now, I hope you will allow me to do this. 5 times 6 is the same as 6 times 5. So in the next line, I would rewrite this as, instead of cos 2x times 5x at the bottom, I much rather say 5x times cos 2x. It is the same thing, just in this form you can actually see the sine x over x more in front of your face, right? Except we have 2x here and 5x there. Usual method. How could we turn 5 into 2? Think about it. How can we turn 5 into 2? 5 multiplied by something that will be equal to 2. What should that something be? 2 over 5, because that will cancel out. So we multiply this by 2 over 5, and then multiply the top by 2 over 5. So we get the limit as x goes to 0 of 2/5 sine 2x all over this goes with that, so we just have all over 2x multiplied by 1 over cos 2x. And I think the construction is finished. It's quiet again. So we know that this will just go to 1. So we would have, and this, we have 1 divided by cos of 0. Cos of 0 is 1, so 1 over 1 is just 1. So that is just 1. This is also 1, and 2/5 will just be. That will just be 2/5. So this answer is not stretching this out anymore. This answer is just equal to 2 over 5. I know this is off the board. 2/5, this is 1, this is 1. So the answer is, this is 2/5, this is 1, and this is 1. 2 over 5, the dot means multiplied by times 1 times 1. 2/5 is the answer. Next question. Alright, we have the limit of x. The limit as x goes to 0 of x multiplied by e to the minus 2x plus 1 all over x squared plus x. So this one looks intimidating, scary, and all the bad words, right? Let's see. Plug in 0, you get 0 over 0, so you write equals 0 over 0, indeterminate form. And you try to, first of all, see if you can factor to x minus a. Could we? Yes, very easily. Yes, very easily. We could rewrite this as x times e to the minus 2x plus 1 all over x into x plus 1. We just want to factor out an x. Just factor out an x. And this goes with that. Remember what we said, once you take out the x minus a, the trouble is done. Now, what